Now here is the second case. Okay. So now the chunks are arranged along z-axis. Again, we want to check the current along x-axis. So earlier case we saw that the chunks were arranged along y-axis. Now the chunks were arranged along the z-axis. So the lower chunk, right, is at position z. The upper chunk is at position z plus dz, right? The lower chunk is carrying smaller bound current, right? Smaller bound current Ix, whereas the upper chunk is carrying larger bound current, and that is why there is a difference in the M bar, right? Difference in the M bar, and this M bar is measured at the position Y. That is why the subscript Y is there, okay, right? Because the chunks were positioned along this, and since the M bar is along Y axis direction, right, it's the single Y position we consider for the M bar, right? Because M bar is along the Y axis direction. But the position of these two M bar is, I mean, these two chunks are at Z and Z plus DZ. That is why it is written like argument. So magnetization is present at Z as at Z plus DZ. Okay. So again, we consider this lower chunk. In the case of lower chunk, you can see the current is coming along the positive, right? Positive x-axis, right? Whereas in the case of the upper chunk, the larger current is flowing along the negative x-axis. You can see that because the band size is larger, because we are taking this upper chunk is giving larger magnetization, and definitely the origin should be the larger bound current. So this larger bound current, we consider this green band, right? It is flowing like this way and it is going like this. Okay. So when we consider this larger current is now along the negative x-axis, whereas the smaller current, smaller bound current is along positive x-axis. Okay. So we, right, when we do this calculation, right, we are getting JB along the negative x-axis direction as written here. Okay, so that is a negative direct, right? Negative value is there. So the change in M bar, right, at position Y, at position Y. So we move along the vertical direction. The single Y direction is there, right? Okay, so change in M bar, right, with respect to change in Z axis. So two chunks are placed right along the Z axis. So that is why change with respect to Z axis, and that gives us JBX, volume bound current density, right, along x-axis. Since it is moving along negative x-axis, we are putting minus sign over there. We are putting minus sign over there. Please write this in the earlier manner, right? Please check this the way it is written here. Please write it in this manner. Okay, so we are looking at the position of the chunks along the y-axis, along the z-axis. So M bar is pointing along z-axis, M bar is pointing along y-axis, and the origin is because of the currents along x-axis. One is along positive x-axis, one is along negative x-axis. So here we combine these two currents, right? So we are combining both terms, right, for currents along x-axis. So we write total JBX, right? Total JBX. You can check that. That minus sign should have been in the middle, right? So you can place plus sign here, right? So check it out here. Now the lower expressions are for the JBY and JBZ. So that is your homework. Please check it out here. For currents along other two directions. Okay, let me complete this. Then I'll give you 5 minutes to complete this particular part, JBY and JBZ. So here you can see that the blank spaces are there, right? The subscript is not there. You can check this. This is given for your job, right? You can see that this is not there. So this is, you had to fill in, right? So So when we are preparing these components like this manner, right, we are actually getting, right, okay. So JB bar is actually given as curl of M bar, right? So how the M bar is getting curl, right, getting position inside that particular chunk. It all depends on the JB current, right? So, right, considering all three components of M bar, MX, MY, MZ, and when we put it in this particular fashion, that gives us the answer for JB bar, right? So, how the bound currents are there, right? But in fact, we know it, right? The JB bar is present there, and that is why we are getting M bar, magnetization, right? So magnetization is by virtue of the presence of the JB bar. So JB bar, right? So all these three components are there. Now you have understood, right? How the curl components are present inside. Okay, so this single example gives you the idea, right? What is meant by this particular determinant, right? So JB bar could be written as this particular determinant. So how the components are present actually when we are looking at this particular vectorial notation, right, of JB bar.